right, we're going to be making some predictions from lines of fit. Now, we might not be familiar with what lines of fit are, but I assure you it will be covered in this quick little video. So, let's take a look at this scatter plot. The scatter plot to the right shows the number of NCAA women's softball teams over a period of years since 1998. Use the 2 points that are labeled to find the slope of the line drawn and describe what the slope means. Alright, so we have the points 3 and 247, and we have the point 7, 264. Alright, so we're going to use that information to do our slope. Here's our formula for slope, and we'll plug in the information from those 2 points. We have 264 minus 247 over 7 minus 3. So what that ends up being is 17 over 4. So our slope is 17 over 4. Well, what does this really mean? Well, I believe what this means is that for every 4 years, there are 17 more softball teams. And it seems to make sense to me. All right, so let's move on. What does it want us to do next? It says, looking at the line, what would you expect the number of teams would be in 2006, or 8 years since 1998? Well, looking at 8 years since 1998 and going up and looking at that arrow, it looks to me like I would predict that the number of teams would be about 268. Alright, so we've got 265 there, and the line goes just a little bit above that, but not quite to 270. So, based on the graph, is the actual number greater or less than your prediction? Well, underneath it is the dot, and the dot is at about 263, 264, so that would be less. So our prediction is greater than what the actual number of teams were for 2006. Alright, so let's talk about line of fit. When real-world data are collected, the points graphed usually do not form a straight line, but may approximate a linear relationship. So even though basically they're not all going to fall into a straight line, they're all going to be somewhat close or show some sort of relationship where you could possibly draw a line. A line of fit is a line that is very close to most of the data points. The line drawn in the graph we just used is a line of fit. So you can see line of fit, and we have an arrow pointing to the arrow or pointing to the line. So are lines of fit, exact? No, they're, it's kind of a subjective thing. You're just trying to get it a line that's showing the relationship of most of the points. So let's try to make our own. Here we have a table showing the ages and heights of 6 different children. Children are going to be very different, and just because one is 2 months in age doesn't mean that one that's 12 months in age is necessarily going to be larger. But they vary, so don't worry, get hung up on the ages and the heights. So let's make a scatter plot and draw a line of fit for the data that comes up. So here's where we'll do our scatter plot. So we have a 2-month-old who was 19 inches, and so we will plot that. We have an 8-month-old who was 23 inches. We have a 1-month-old who's 21.5 inches. We have a 12-month-old that's 22.5 inches. A 5-month-old that's 20 inches, and a 6-month-old that's 22.25 inches. Okay, so those are our plots. Now remember, plots don't necessarily form a straight line, so we can see that there's sort of a relationship in there. So I'm going to draw in a line of fit, where I think the line of fit should be. All right, now what would be the purpose of this line of fit? Well, the purpose of the line of fit is it might help me predict something. And in this case, we're going to use the line of fit to predict the height of a 16-month-old. So but once again, it's just a prediction. Is it exact? No. But based on our line of fit, we can predict that a 16-month-old child is probably going to be about 25 inches.